Today we're going to start a lesson on mole to atom conversions. What I want to start with is something you already know, and that is counting numbers. So if you've ever gone to a bakery, whether to get donuts, bagels, cupcakes, you've probably used the term dozen before. And so pictured here is 1 dozen. And so you probably already know that 1 dozen, if in my example I have cupcakes, so 1 dozen cupcakes equals 12 cupcakes. And you probably heard, if you've gone to Panera, of a baker's dozen, where you have 13 cupcakes, because a baker's dozen is a dozen plus an extra one for the baker. Here in my middle picture, I have a pair. Another counting unit we're probably familiar with. And this is 1 pair of shoes, which equals 2 shoes. If you have a pair of anything, you have 2. Over on the right side, I have a picture of roses, and this is actually a gross. A gross may be a counting unit you're not familiar with, but a gross is 12 dozen. So in this picture, I have 1 gross of roses. And so that would mean I have 144, 12 times 12, 144 roses. In chemistry, these counting units are too small because we're talking about really small particles. We're talking about atoms. We're talking about molecules. And so we can't just talk about 2 atoms or 12 atoms or 144 atoms. We need a much larger counting unit. And so in chemistry, our counting unit that we use is called Avogadro's number. Which is the mole. Avogadro is a scientist who developed the mole definition. And so the definition of a mole is an amount of a substance that contains as many particles as there are atoms in exactly 12 grams of carbon-12. Well, you're probably wondering, well, how many atoms are there in exactly 12 grams of carbon-12? And so 1 mole of anything equals 6.022 times 10 to the 23rd particles. If you're in the chemistry room, the next time you're in your chemistry classroom or any of the 4 chemistry classes, in the back wall, there's a large number written out in standard notation that is a mole. It's not written in scientific notation. It has all the zeros behind it, but it is the number of particles in 1 mole. Another fun fact about the mole is that in October, chemists celebrate the mole because you have 10 So on October 23rd, from 6:02 a.m. to 6:02 p.m., chemists and chemistry teachers and students celebrate the mole on October 23rd from 6:02 a.m. to 6:02 p.m. So if we think of our phenomena, 1 mole of copper equals 6.022 times 10 to the 23rd atoms of copper. Our other element in our phenomena is aluminum. So if I have 1 mole of aluminum atoms, equals 6.022 times 10 to the 23rd atoms of aluminum. So what can we do with this number? Well, we can do conversions, and we're going to start with a small one-step conversion, and we will be building on this throughout the year. So I'm going to do 2 examples now, and then the next time you're in person in class, we will go over more examples of these types of conversions. So we're doing particles, and in this case, our particles are moles, our particles are atoms, and we're converting from particles to moles. And you do that conversion with Avogadro's number. And you can go from atoms to moles or moles to atoms. These problems are done with dimensional analysis. So if you did not understand dimensional analysis in Chapter 2, you need to come in and see your teacher. You cannot just move the decimal point. You have to be able to set up your problems using your units. You also need to know sig figs because every problem has to be solved with correct sig figs, and you have to include units. So our first example, how many moles of copper are in 2.55 times 10 to the 22nd atoms of copper? So this is what I have. Whoops, too far. So I'm going to write that on the top of my railroad track. So I've seen some of you not using this over here to the left bottom as a placeholder. You've been putting numbers there. So put a 1. This is a placeholder. You should not be writing any of your conversions there. The units here, atoms of copper, I'm going to write at the bottom of my first conversion factor. So these match. I'm asked for moles of copper. So those units there go on the top. If you notice, I did not put any numbers in. I only have units. When I look at my units, it's moles and atoms, which is Avogadro's number. And the definition of Avogadro's number is that 1 mole of anything is 6.022 times 10 to the 23rd atoms. Now, solving these dimensional analysis problems, you multiply what's on the top. You multiply what's on the bottom. Then you divide. So I recommend putting what's on the top in parentheses divided by what's on the bottom in parentheses in your calculator. The other thing to remember, and you need to try this calculation, pause the video, try it in your calculator. You do not put in times 10. You do not use a caret button. you should be using the expressed exponent, the EE. So on the calculators that we have in our classrooms that we've showed you, the TI-30X2, it's second and then the x to the -1. If you have a personal graphing calculator, you select the second button and then it looks like a comma. It's the button above the 7. If you are unsure, the next day you are in class, you need to ask. So you plug this in your calculator. Diagonally, these units cancel, so we get the units we want, which are moles. Looking at my numbers, 2.55 is 3 sig figs. 6.022 is 4 sig figs. When you multiply and divide, it's the least number of sig figs from the problem. So I should have 3 sig figs. The answer is 4.23 times 10 to the -2 moles of copper. If you did not get that in your calculator, you need to try again. Make sure you didn't use the times 10. Make sure you didn't use a caret. Make sure your calculator's in scientific mode. If you're still having trouble, please see your teacher about how to properly use your calculator. We're going to do a second example. This one, we're going to start with moles. We're going to start over here and convert to atoms. So I'm going to start with 0.345 moles of aluminum. I'm going to put a placeholder here. Now, you see I wrote MOL. That's the abbreviation for moles. You can't use a lowercase m because lowercase m is for meters. You can't use a capital M because that's a unit for molarity. Can't use MO because that's an element on the periodic table. So the abbreviation for moles, if you want an abbreviation, is MOL. These units, moles of aluminum, so this unit here, I move down. So they should match. Because that's what I have here. What I'm asked for is how many atoms of aluminum. So those units go on the top. Looking at my units, atoms and moles, it's Avogadro's number. And that definition is wherever the unit's mole is, 1 mole of aluminum is 6.022 times 10 to the 23rd atoms of aluminum. Again, this is a good place to pause the video, plug this into your calculator, and see if you get the correct answer before I write down the answer. Again, you multiply your numbers on the top of your railroad tracks, you multiply the bottom numbers, and then you divide. These units cancel. So I get the units I want, which are atoms of aluminum. I have 3 sig figs here. I have 4 sig figs here. So my answer should have 3 sig figs. So it's 2.08 times 10 to the 23rd atoms of aluminum. If you did not get that, please talk to your teacher so that we can help you figure out what's going on with your calculator. We will continue to use Avogadro's number throughout the year. We'll be building on it in this chapter in our next set of calculations.